Welcome to Central Otago. It's autumn time. A hot, dry summer is coming to an end, and a long, cold winter awaits. Welcome to our eco-friendly building site, where a new home is in the process of being built. A straw bale home with earthen plastered walls. On site, a sustainability workshop has been held to build an efficient wood-fired heater for the home. A special type of wood-fired heater with a bake oven is going to be built. The design hails from Finland, where they are virtually a household necessity. Kachelofen, tiled heater, Russian oven, Kong, ondol, rocket stove, masonry heater. Since ancient times, cultures all over the world have been developing better, more efficient ways of cooking and heating using wood. And now, this tradition of wood-fired heater is being introduced here in New Zealand. In this presentation, you will catch a glimpse of a masonry heater being built. You will learn about how the heater works and its features. You will be shown the difference between a masonry heater and common wood-fueled devices. And you will be given insight into an age-old tradition of heating that both make sense environmentally and from an enjoyment point of view. Homeowner Samsa Kiuru has organised a masonry heater workshop to give a bunch of Kiwi tradesmen an authentic, hands-on learning experience. Albie Barden from Maine Wood Heat Company in America has been flown in to instruct the workshop.
So you've got ovens going back, 2, 3, 4,000 years as the kind of starting spot. The traditional unit in Germany, Austria, and Switzerland is called a Kachelofen, with a h in your Kachel, and that simply translates into tiled oven or tiled stove. Historically, whether you started in Finland or you started in Austria, the device you started with was an oven. Or in Germany and Austria, it's an ofen. And then, since you had an ofen or oven in your house, cooking and baking as the essential cooking tool, lo and behold, the thermal mass of the oven also gave off heat. So they figured out ways to add benches to the ovens, and then they figured out ways to put cook surfaces. But the root of all of this tradition is the oven function. In Russia, it was very common, and in parts of eastern Finland as well, it was very common to sleep on top of the oven. So you had an oven and an open hearth cooking capability, to which was later added a cooked surface in the traditional kitchen, and there were normally masonry stairs up the back of the oven to a platform. That was the warmest place in the house. And I think it goes all the way back to Afghanistan, Korea, and China. And China ran out of wood long before any of us even thought about running out of wood. So the traditional form of heating a house in China was you didn't heat the house, you heated the space you were sleeping on or sitting on. And the traditional form in China was called a K-A-N-G, Kang. In Korea it was called an ondol. So basically imagine doing your cooking at this level, and then you're running your cooking exhaust through a labyrinthine channel, which is a heated platform about this tall. And that heated platform is what you can sit on during the day, and at night you just lay on it like a bunch of sardines. That's the warmest spot in the house.
While Albie instructs, parts and pre-cut sections of the heater lay scattered about the work area. Assemblies are pre-cut out of red marine brick for the heater's exterior shell and yellow fire brick for the heater's high-temperature refractory inner core.
And it's the primary heat source in a green...
Hardware elements come from Tuulikivi in Finland, a company which produces around 10,000 heaters a year. The heater will also feature a soapstone decorated exterior. Soapstone is a traditional material used in masonry heaters that reacts well to heat and fire. The soapstone, although not common, is native to the South Island of New Zealand.
Now, did that cut easier than you thought it would?
Yes.
The workshop's first task is to fabricate the heater's lintels and roof structures, parts of the heater that are not easily made out of brick. A high-temperature ceramic mix is quickly prepared and poured into purpose-built castable frames.
This is over the firebox. If this develops a crack in the middle, these wires are going to hold things. Alright, we need to take this out and wash it out. And
Wrap it, it should stick to your trowel.
Along the way, the workshop group is taught a set of masonry skills to ensure everyone learns about proficient bricklaying. Albie demonstrates basic bricklaying technique to beginners.
you see what I did? That little bit of a shake was to just get that mortar where I wanted it so that it wouldn't fall off when I did that. And I'm creating a uniform joint just with my eye.
There we go. We're going to make sure this front edge is fine.
Yeah.
And swap it
And it's perfect.
sure. I only saw him do this once, but
So here's my plan.
all right.
Cool, mate. Yeah.
This
Perfection
right
from the
here,
master.
and just pay off.
Now you've got too many people when you go in the far window. Come back again.
There are plenty of tasks for everyone on site. Here, the porous bricks are saturated to avoid drawing too much moisture from the quick-setting mortar. Construction begins with laying the heater's footprint on top of a solid concrete foundation. Then, the first 5 courses of the heater's outer shell go up, followed by the back wall. Next, the inner core is assembled using yellow fire bricks. Looking at a model of the incomplete heater at this stage can reveal a masonry heater's inner workings. Let's take a cross-section and look at what's been built piecewise. At the bottom of the heater is an ash box and air intake, where the fire feeds itself oxygen.
It's not quite enough.
On the inside of the fire pit, the air is distributed by brick channels resembling a sunburst.
Well, it'll start to pull.
The channels ensure a good distribution of oxygen to the fire.
Gets too much ahead of you, then
The firebox is then lined with a replaceable brick veneer, which comes in contact with the fire. The heater's inner core uses refractory materials, meaning the fire burns intensely hot. This allows complete combustion of initial exhaust gases that escape unburned in most wood-fueled devices. When Sumpser gets his heater up and running, hot exhaust gases from a large fire get sent on a long journey through the heater's internal structure. Above the firebox is the heater's oven. Baking tiles in the oven are set aside during a burn, welcoming the fire's afterburn. You could imagine jets of flames shooting up and through the oven like a set of spiralling ram horns. After the exhaust has done its dash in the oven, it escapes through a roof vent. Then, the hot exhaust heads into a downdraft. The structure of the heater forces the exhaust downwards towards the base of the heater. Then the exhaust gas makes its way through a horizontal vent and finally out the chimney.